Hello everyone, this is Charan Godachar, Department of CSCCY, pursuing my education in Sri Venkateswara College of Engineering. Today my presentation is about KRUSKAL's algorithm. Introduction to KRUSKAL's algorithm. KRUSKAL's algorithm is a popular method for finding the minimum spanning tree of weighted graph. It was used by Joseph KRUSKAL in 1956 and has been widely used in network design. Understanding this algorithm is essential for solving various optimization problems in computer science and engineering. What is minimum spanning tree? A minimum spanning tree is a subset of edges in a graph that connects all vertices without cycle. It minimizes the total edge weight while ensuring connectivity among all vertices. Minimum spanning tree are crucial in applications like network design, clustering, and circuit design. Overview of graph. A graph consists of set of vertices and a set of edges connecting pair of vertices. Edge can be weighted, implying a cost or a distance associated with traversing them. Graph can be directed or undirected, but Kruskal's algorithm typically applies to undirected graphs. Disjoint set data structure. Disjoint sets help manage and group elements into subsets. Each set in the disjoint set structures can be represented with tree-like structure. This data structure supports two main operations like union and find, which are crucial for Kruskal's algorithm. Steps of Kruskal's algorithm. Begin by sorting all edges in non-decreasing order based on their weights. Initialize a disjoint set of vertices in graph. Iterate through the sorted edges and add them to the minimum spanning tree if they do not form a cycle. Sorting the edges. The first step involves in sorting the edges, which takes zero time complexity. Efficient sorting algorithms like quicksort or mudsort can be employed. The order of edges is critical as it determines which edges are considered first or inclusion in the minimum spanning tree. Initializing the disjoint set. Each vertex starts in its own distinct set representing individual components. The union operation will merge two sets when edge is added to minimum spanning tree. Path compression can be used during the find operation to optimize future queries. Iterating through the edges. Process edges in the sorted order, checking if they connect to different components. Use the find operation to determine the root of the each vertex set. If root are different, the edges can be added into minimum spanning tree and the set are merged. Adding edges to the minimum spanning tree. An edge is added to the minimum spanning tree only if it connects two different sets. This ensures that no cycles are formed while building the trees. Once all vertices are connected, the algorithm concludes. Time complexity analysis. The overall time complexity of Kruskal's algorithm is zero. This is primarily due to the sorting step, while the union find operation are nearly constant time. The algorithm is efficient for the square graph, where E is much lesser than V square. Space complexity analysis. The space complexity is zero, accounting for the storage of edges and the disjoint set structure. Each edges and vertices need to be stored and managed during the algorithm execution. Efficient memory management is essential for handling larger graphs. Examples of KRUSKAL's algorithm. In the image, we can see that the graph consists of 1, 2, 3, 4, 5, 6 edges, and we need to find a minimum spanning tree with no cycle. Here we see that 1 to 2, 2 to 3, and 1 to 4, 1 to 5, and 2 to 6. Advantages of KRUSKAL's algorithm. It is simple to understand and implement, making it accessible for beginners. The algorithm efficiently handles spare matrix or graphs, providing optimal performance. It ensures that the minimum spanning tree is globally optimal due to its greedy nature. Limitations of KRUSKAL's algorithm. The algorithm requires all the edges to be known beforehand, which may not always be feasible. It may not be efficient on dense graph compared to the algorithms like Prim's algorithm. The overhead of sorting can be costly for graphs with a large number of edges. Applications of KRUSKAL's algorithm. KRUSKAL's algorithm is widely used in network designing, including telecommunication and computer networks. It is also applied in the cluster algorithms to minimize distance between points. The algorithm finds use in circuit design to minimize the total wiring length. Thank you.